Today we will see a new topic that it's called factoring by grouping. In this case of exercises, we have a polynomial with no common factors. We cannot take out a common factor of the whole polynomial. It will normally be composed of 4 or 6 terms. That's a form to identify it. We must have maybe only 4 or 6 terms. For this case, we will inspect the polynomial to find out that they are like two groups in the polynomial that between them have a common factor. So that it's the important part. We will separate parts of the polynomials, and we will see that for a part of a polynomial, we will get a specific common factor on each part of the polynomial. So the steps for this kind of exercise is first, identify the polynomial and separate it in the two groups of terms that have common factors. Then on the second step, we will take out the common factor of each group. After doing this, step 2, the exercise will be seen as a greatest polynomial factor exercise. So after doing exercise or step 1 and step 2, we will see that the specific exercise will become a greatest polynomial factor exercise. So then we will need to write the greatest polynomial factor in one parenthesis and the other terms in the second parenthesis. If possible, we will do like term simplification, and of course we will need to order our answers at the end. So after this specific explanation, we will start seeing some exercises of factoring by grouping. So let's see the first exercise. If we see in this specific exercise, we have a polynomial composed by 4 factors, and between them, I cannot take out a monomial common factor of all of them. So I need to separate it in two groups of terms. I can separate these two terms that have x and these two terms that do not have x. And then we need to take out what is the greatest monomial factor on each group of terms. So for the first group of terms, we can take out an m. So if I take out an m to become m squared, it's going to be multiplied by m. M to become plus mn, it's going to be only plus n, because m multiplied by n, it's mn. And from the second factor, I can take out an x. So I open up the parenthesis, x to become mx multiplied by m. Mx to become nx multiplied by n. In this case, we can see now that it has been created, or the problem has become to a greatest polynomial factor exercise. So we can continue as a greatest polynomial factor exercise. The greatest polynomial factor on one parenthesis, the other terms in the other parenthesis. It's correctly ordered. I cannot do like term simplification, so this is going to be our final answer of this simple exercise. So as we saw, doing a factoring by grouping, it's separating in groups that has a specific common factor, and then the exercise will become a greatest polynomial factor exercise. So let's continue with other examples. So let's see, on this second exercise, we have something like this. Another time we have 4 factors that doesn't have anything that it's common for the 4 of them. So in this case, I need to group them. Maybe in this case, it's better to group them. You can group them whatever you want, looking for common factors. In this case, I will select those that have 3 and those that do not have 3. So I will put it like first those that have 3. After that, those that doesn't have 3. So I selected to do it like that, but you can select maybe different ones. The important part is that they have a specific common factor between them. So in this case, from the first two terms, I can take out a 3x. So 3x to become 3x cubed, we need x squared. 3x to become 3x, it's only 1. And if you see here, maybe the other part, it's very similar, minus x squared minus 1. So I can take out a minus 1 multiplied by x squared, it's minus x squared, multiplied by 1, it's going to become minus 1. So now the exercise has become a greatest polynomial factor exercise. So it's going to be on the first parenthesis x squared plus 1. In the second parenthesis 3x minus 1. I cannot do like term simplification in this case. I cannot take out anything of a factor. So that is going to be our final answer. X squared plus 1 in one factor that multiplies 3x minus 1. So let's continue with the next exercise. So let's see, in the next exercise we have something like this, also very similar, 4 factors that between them I cannot take out a common factor for all of them. So I need to like put them in groups of 2. In this case, maybe I can put those that have x in one group, those that have y in one group. You can do it maybe those that have a squared and those that do not have a squared. You can do it whatever you want. So in this case, it's going to be 4a squared x minus 12bx minus 5a squared y plus 15by. So from the first terms, I can take out a number 4 because all of them are divisible by 4. And I can take also an x. So it's going to be multiplied by a squared minus b. In the second one, I think I can take out a 5y. If I can take out a positive 5y, 5y, it will be multiplied by minus a squared. That's why, to be the same as the other parentheses, I will take out a minus 5y, because minus 5y multiplied by a squared, it's going to be minus 5a squared y, and it will be similar than this one. Then minus 5y to become, here I forgot, it's minus 3b. It's a squared minus 3b, not only b. Here on the second part, it's minus 5y that multiplies a squared plus, not, it's minus multiplied by minus, it's going to be plus 3b. So in this case, it's going to be now a greatest polynomial factor exercise in which we can select the one that it's common on the first parenthesis, the one that it's not common on the second one. In this case, I cannot take out anything of any parentheses. I cannot do any type of ordering because it's correctly ordered. So in this case, this is going to be our final and correct answer. So as we saw, it's only looking or creating a greatest polynomial factor exercise by grouping different type of terms. Maybe some of it can take it or do this exercise comparing these two of them because they have a squared, and comparing these two of them because they have b. So it's up to you creating the groups that will help you to create a greatest polynomial factor exercise. That is the important part to answer this exercise. Let's see another example. So in the next exercise, it's going to be something like this. Remember, we need to create two groups of two terms. So in this case, maybe I can use the first two because they have x to the 4, and the second two because they don't have x to the 4. So on the first one, the common part is x to the 4. X to the 4, it's going to be multiplied by 2m plus 3n. On the second part, we can take out a number 5 that is going to be the common, and it's going to be multiplied by 2m to become 10m, and multiplied by 3n to become 15n. So here I can put it in correct order, and it's going to be 2m plus 3n, and in the second parenthesis, x to the 4 plus 5. I cannot take out anything on the parentheses, it's correctly ordered. So this is going to be our final answer. So now I will start doing exercise with 6 terms instead of having 4 terms. So it will be a little bit different. So let's see the next examples. So let's see, in this specific exercise, we have 6 terms. So if we got 6 terms, it will be a factoring by grouping. Remember, we need to make 2 groups. In this case, it will be groups of 3 terms. I will select these 3 of them because all of them have 2 and also they have a. Of course, this will be the next group. So let's start with the first group. On the first group, I can take out a number 2 and also an a. So to become 2am, we need an m. To become minus 2an, we need a minus n. To become 2a, I need only a plus 1. So if we check out this one, it's very similar to the other part, only with different signs. So for the second group of terms, I can take out a minus 1, and it's going to be to become minus m multiplied by m. To become plus n, it's going to be multiplied by minus n. To become minus 1, it's going to be multiplied by plus 1. So here we can see that their actual exercise has become a greatest polynomial factor exercise, so we can continue doing it. Remember, we will put the common term or the polynomial common term in one parenthesis, those that are not common on the second parenthesis. I cannot take out anything. I cannot do like term simplification. I cannot order because it's correctly ordered. So this is going to be our actual final answer. So as we saw, it's the same doing this type of exercise with 4 or 6 terms. The different part is when we have 4 terms, we make 2 groups of 2 and 2. When we have 6 terms, we need to make groups of 3 and 3. So let's go with another exercise. So in the next exercise, we have also something with 6 terms. Maybe here it's not easily seen that we can have something that has a common factor, but in this case, let's see. We have 3, 2, 2, 6, 3, and 4. So we can put those that are divisible by 3 in one group, maybe those that are divisible by 2 another group. So we can put it like a 3ax plus 3ay. We can put the minus 6a at the beginning. And on the second group, it's going to be plus 4b minus 2bx minus 2by. So let's see. On the first term, we can, or the group of terms, we have those that have something in common, these that have something in common. So on the first one, we can take out a number 3 and also an a. So it's going to be multiplied by minus 2 to become minus 6a, multiplied by plus x to become 3ax, plus y to become plus 3ay. And let's see on the second one. On the second one, we can take out a number 2, b. So it's going to be multiplied by minus 2. So we will need a minus 2 here to be similar that the other parentheses. Minus 2b to become minus 2bx, we need plus x. On the third one, minus 2b to become minus 2by, we need plus y. So now we have converted this specific exercise to one that it's greatest polynomial factor exercise. So we will write the common polynomial factor on one parenthesis and the other terms on the second parenthesis. So remember, the answer must be ordered to be correct. In this case, it's not correctly ordered because on the trinomial it must be x plus y minus 2 that multiplies 3a minus 2b. And this is going to be our actual final answer. So as we saw, sometimes it's not very easy to see three terms that have something similar between them, but the actual part is to identify, inspect the polynomial and find those two groups that between them they have a common factor, and the exercise will become a greatest polynomial factor exercise. Let's do one last example. So let's see, in this last exercise, it's going to be something similar, 6 terms. We need to separate them into groups that have common factors. In this case, we can see that some terms have a squared b cubed, so I will take out those 3. And of course, those that have n to the 4, so I will write it like a squared b cubed plus a squared b cubed x squared minus 3a squared b cubed x. Then in the other groups, it's going to be minus n to the 4 minus n to the 4 x squared plus 3n to the 4 x. So for the first group, I can take out a squared b cubed. To become a squared b cubed, it's only multiplied by 1. To become a squared b cubed x squared multiplied by x squared. To become minus 3a squared b cubed x multiplied by minus 3x. On the second parenthesis, we will take out an n to the 4. So it's going to be minus 1. So we need to have the same factor inside the parentheses. So I will change it. I will take out a minus n to the 4 to become minus n to the 4 to become minus n to the 4 multiplied by 1. Minus n to the 4 to become minus n to the 4x squared multiplied by plus x squared to become plus 3. So it's going to be multiplied by minus, porque minus multiplied by minus, it's plus. Then minus 3 multiplied by minus n to the 4, it's plus 3n to the 4. We lack an x here. So now the exercise has become a greatest polynomial factor exercise. So we will write the parentheses that it's common on the first term, and on the second factor we will put the ones that are outside the parentheses that are now the common polynomial factor. So now I need to put it in correct order to be correct. So the first parenthesis or the trinomial must be x squared minus 3x plus 1 that multiplies a squared b cubed minus n to the 4. It's now correctly ordered, so that is going to be our actual final answer. So this type of exercise is called factoring by grouping. We only need to identify the polynomial, inspect it, and after that separate it in groups of terms that they have a common factor between them. Remember, if our group of factors is 4 of them, or our group of terms are 4 of them, we will use 2 groups of 2 and 2. If we have 6 terms, then we will do 2 groups of 3 and 3 terms, and it will become a greatest polynomial factor exercise after using the common factor between each group. So it's everything for today. That was the topic called factoring by grouping.